it said that, and I happen to agree, that the lazier you are, the better developer you will most likely be. Which is true when you think about it. A lazy developer, or a lazy person, is someone who wants to get the job done, because they're not incompetent. They want to get the job done, but they want to do it with the least amount of work possible. So if they need to code something as a programmer, they don't spend all their time creating crazy abstractions and layers and complex configurations and tweakable and look, and then this could run and you could have this thread pool and this does all this stuff. They do the minimum it takes to get the job done. And as a result, not only do they get it done quicker, but there's less moving parts, less things that can go wrong, and it's easier to maintain down the road. Now, plugin development is something that I think particularly appeals to the lazy people. How many of you would consider yourself lazy? Thank you. Yay, good. So we're all lazy people. We don't like to do a lot of work. And plugin development is perfect for that. I mean, you think about it. So you're sitting there in bed, maybe, or maybe in a more sane place, and have an idea. God, I wish I could do whatever. And yeah, you could go away and you could, pull out a Tomcat instance and you could write a servlet and you could start writing your web framework and do all this stuff to get that thing done. And about 5 months later, you'd have Hello World. Or you could write a plugin. And you get so many things for free with plugins. You get security, you get a UI layout, you get REST services, you get database access, soon to be very nice database access. You get all these things for free, so you can get a plugin done in a couple hours. And I don't know about you, but that's how it always turns out to be. I have an idea, and I say, God, I really want to do this thing. And so I say, you know what, that's like 2 hours. Crap, I'll just sit down and just hack that shit out. Hack that stuff out. Again, apologize if I offend anyone. I used to do preaching, which actually kind of made it almost worse, because you really can't curse during that. Anyways, so you spend 2 hours, you're like, oh, I'll do that. And of course, it doesn't take 2 hours. It always takes 4 or 6 because you had an idea problem or Maven's being a pain or something like that. So, but 6 hours and then you get something and it works. And you're like, oh, this is awesome. And so the next step is to deploy it. I want to start using it myself. So you spend another hour, maybe another day, getting it all nice and polished so that you can bribe and cajole and whatever it takes to get the system administrator of your local Confluence instance or Jira to install the plugin. Then you start using it. And oh, this is really cool. And you say, boy, I wish it did this other feature and this and this. And your other users start saying, oh, I want it to do this and this. So you start adding feature after feature after feature to your plugin. And then you say, you know what? I'm going to be a good citizen. I'm going to put it up on pack. And so you go back into the code and you make sure that you take all those hard-coded strings all over the place that you know you have, hard-coded passwords, I'll bet some of you. I do it all the time. And you got to take that stuff out because it's going to go on pack. And you spend all the time doing the polishing. You add a description to your POM and you make sure all your plugin modules have nice names and maybe internationalization if you're crazy. So you spend crazy if you're a good citizen. Maybe write some docs if you're just that great of a developer. So you spend all this time making it all nice. That's another 2, 3, 4 days, maybe. Then you put it up on pack, and of course people start downloading it. They start loving it. They start sending you email requests saying, can you add feature X? Now, of course, feature X is not at all what you intended the plugin to be in the first place. But you're like, well, yeah, I guess how I could see you'd want to do feature X. And so you start adding feature X and feature Y, and you start restructuring and refactoring your plugin. And soon, you not only have all these features that you want, you have all these features that other people want. And as we know, for anyone who's gone through that process, it's not simply a matter of adding feature, adding feature, adding feature, done. What usually ends up happening is you add a feature, break 3 things, try to fix them, fix them. Those fixes broke 2 other things. You fix those, fix those. And it gets worse and worse, exponentially worse, as the plugin continues. Because at first, it's just features that you use. And then you start adding in features that the community uses, that you don't use yourself. And so when you code and add a new feature, you'll probably break those features. But since you don't use it yourself, you never hit that bug. And so you get a bug report from someone, oh, you completely broken, you spend all this time fixing. So the lazy developer, the person who's doing plugin development, will look at the big picture and say, how can I minimize the amount of work I have to do to get this plugin done, to add the features out in the world? And the answer, as you might have guessed from the title, is, I believe, functional testing. I shouldn't say the answer. I should say a answer. A way to mitigate and minimize the amount of work is functional testing. And I like to think of it this way. How many Plants vs. Zombies fans do we have here? Plants vs. Zombies. Just a few of you. How many people have iPhones? Okay, you all have no excuses. How many people have iPads? Jeez. Okay, cool. Get it for that too. How many Windows? At this point, everyone should have raised their hand unless you're sleeping, which is probably a number of you. Or Linux. I think actually I got it to run on Linux. Hey, Linux guy, cool. So Plants vs. Zombies is a tower defense game. It's one where you want to get money, and in this case it's suns. It's kind of cute. And so you plant sunflowers, because sunflowers, as we all know, produces suns. So we plant all these sunflowers, and we get more and more suns, and more money accumulates. And this is like software development. We just want to write feature after feature and get all those good, neat, cool things in there. And then comes the zombies. Because the zombies, of course, hate plants, and they want to eat plants, as we all know. So the zombies are coming in, and you're trying to do the sunflowers, but shit, darn, the zombies are coming. What do we do? Well, the logical thing to do is drop a cherry bomb on them, because that blows up the zombie. Neat. Well, that's very expensive, and you have to do it on every single zombie. The better way to defend against the zombies is to use pea shooters, because as we know, all zombies hate peas. So we plant a bunch of pea shooters, and the pea shooters just sit there and shoot peas at the zombies, which of course kills them. And then that leaves you free to go back and plant your sunflowers. So it's like that in programming. So we want to write all these features. We want to just sit there and add this, add that, make it all cool and spiffy. But the zombies are coming. The bugs are coming. The regression things are coming. You can't stop them. You kill one or two, and you always think, oh, now it's bug-free. No, there's just more zombies that are off-screen that you can't see. So the zombies start coming. The best way to do that is start mounting a defense, or as I'll argue, a selenium defense, where you start putting tests in place to protect against those bugs. Sure, some zombies will get through, but a lot won't. So that's what we're here to talk about, is functional testing. Now, I think I'm just going to make a statement. I think we all agree that functional testing is generally a good idea. So I'll skip that aspect, and we'll go straight to the next line of questioning, which is, how many of you actually write functional tests for your plugins? Okay, so 10, 15, maybe 16% of you. Actually, it's interesting. I always wondered if it'd be everybody or nobody, and so, but okay, 16%, that's fair enough. How many of you who raised your hand write complete end-to-end Selenium browser-based testing? Okay, some Atlassian guys and Roberto, who gave the graded Selenium lightning talk. The rest of you, this is good, because I'm actually here to talk to mainly the rest of you. So you don't write Selenium tests. We all agree that functional testing is good. We should do it. I talked about how it makes life easier for you. Fair enough. But you don't do it. I don't do it a lot of times. I don't do it most of the time. Why is that? So we're going to be a little old school over here. We're going to use a whiteboard, and I'm going to write up some reasons. Because, again, being the lazy person I am, I could come up with fancy slides. And I said, you know what? Screw that. Let's use a whiteboard. Why not? Talk to me. Why do you not write functional tests for your plugins? This is the part where you raise your hand or something. Speak out. Okay, fair enough. I'm not sure how I solved that particular problem, but all right. Yes?
Don't know where to start.
Don't know where to start. Good one. Oh, geez. All right, so here's the thing. So it looks like you can't read this. In the back, that's fair enough. The people in the front, they can't read it either, so don't worry about it. Yeah, you kind of know what I mean. Anyone else? Come on, give me some reasons. Why do you not write functional tests? Yes, Sam.
Hard to set up.
Hard to set up. Good man. I planted that answer. All right, give me another one.
Don't have time.
Pardon?
Don't have time.
Don't have time. No time.
They're brittle.
Yes, Roberto. Wait, what?
They're brittle.
Oh, they're brittle. Yes, sorry. Brittle. That is a huge, B-R-I-T-T.
Sure.
Yeah, that works. Yes, Dan.
Too many false positives.
Too many false positives. Good. That's where you think things are broken and actually they're not. Your tests just suck. POS.
Requires too much data.
Good. Too much data. Too much data. Not sure what you're testing. Good. Jeez. Maybe I should have typed. All right, give me another one. What was the one that I heard? Too many version dependencies. Okay, version dependencies. All right, give me another one. Oh, sure, everyone talks at once and then everyone doesn't have anything to say. Yeah.
Sets up for a very short test.
Lots of setup. Good. I like that. Lots of setup. And also think, and why don't you think about this? Think of end-to-end Selenium testing. Why do you not do Selenium testing? Because that's specifically what I'm going to be talking about. Time it takes to run. Yes. Too slow. Good. So instance execution dependent variables. So too many variables, okay? Whew, getting high up here. All right, give me another one.
Automated nightly builds?
Ah, the nightly build problem. In fact, just getting it running on Bamboo in general, especially with Selenium, can be Bamboo, because I'm sure that's what you're all using. Yep, give me another one. Okay, well that's fair enough, that's pretty good. I'm going to add my own, because I have my own biases to this. Too much Maven. Because in order, how we do functional testing internally, we have all these different Maven plugins we have to set up, and it's just a gigantic amount of Maven POM. And if you know anything about me, I am not a fan of Maven. I think it is a pain in the ass.
Blasphemy.
What?
Blasphemy.
Blasphemy. Yes. I'm sure you're all a bunch of Maven lovers. Maven lovers, everyone? Yeah, right. Okay, that's what I thought. But Maven is very valuable. Okay, so we're not going to get distracted onto Maven. So we're here to talk about functional testing. So this is a good list. We have a lot of reasons why we don't do functional testing. I'm sure if we thought about it and if we think back into some projects that we've done, we could just keep going and going and going. So what I want to talk about next is I want to show you a library that we've started to use internally and that I think helps to solve some of these issues. I'm not going to be an idiot and come up here and say, hey, I have the silver bullet, use what I use and everything will be great. It's a pain in the ass. Functional testing, integration testing will always be a pain in the ass. It's just, could you make it more of a pinprick instead of a dagger shoved right there? So how I'm going to do is that, I'm going to show you a library. The library is called Atlassian Selenium, because we're very imaginative at Atlassian, and it works with Selenium, as you might have guessed. Atlassian Selenium, to show off this library, I'm going to take a plugin that I wrote for FedEx called the Confluence Likes plugin, and we're going to add integration tests to it. And that's pretty much the summary of my talk. So here's the Confluence, as you can see. So the Confluence Likes plugin, what it does, it adds a likes button to comments. So that you could say, hey, this Confluence comment, I really like it. And so you can click the button, and then it says how many people like the comment. It's a half-done FedEx project that I did once. It's absolutely not ready or useful in any form. However, I thought it might be a good one to use to show off functional testing because it's written completely in JavaScript. So everything is asynchronous, AJAX loaded, which makes the traditional testing methods that you may have used, like JWebUnit, not quite so great. So here's the Confluence instance, and I'm going to add a comment, just so I can show you how it works. And also, we're going to write a functional test, which is going to automate this. So we clicked on that. Just because I am a wiki markup nerd, I'm going to go there. Hello, world. And then I'm going to add this comment. And there you go. Now, the couple things you notice. First is we have a like button down at the bottom. Yes, that is a web item. However, we use a bunch of JavaScript to override the click event so that we can do some fancy JavaScript magic. And then over on the right, you see how many people liked it. So no people liked it so far. It's a brand new comment. I'm going to click like. And then it turns to dislike, and over there you can see the number incremented to 1. So very, very, very simple, useless plugin, but it's showing how all this JavaScripty stuff with AJAX and all that can be handled. Because if you've ever done any Selenium, you'll know that AJAX is a user's best friend, but a tester's worst nightmare, because it's just all asynchronous and you have to do all these waits. Anyways, we're getting ahead of ourselves. So that is the plugin. Pretty straightforward. I'm going to remove it because my test kind of assumes that there's one. And I always forgot to do that when I was practicing. Here's the code behind the plugin. So the Confluence Likes plugin. I'm not going to go through how the plugin works. As I said, the plugin itself is not really that interesting. I'm just going to start writing a test. So we have our integration test. And if you've ever used AMPs, which I think many of you, some of you, good amount of you use, if you ever want to write integration tests, you may or may not already have known this, you start the package with IT. And if any test in your unit test directory, if the package starts with IT, it will automatically be executed in the integration test phase and not the unit test phase. And since I'm a bad programmer, I don't have any unit tests apparently. which I don't recommend. That's bad. So we're going to write a test, and we'll call this test likes for the hell of it. And away we go. So we have our test here. Now, instead of just kind of jumping in, I want to kind of ease our way into integration testing or functional testing, whatever the term of the day or what you prefer. So what we're going to do is I'm going to write a very simple test which will simply start up Selenium, start up the browser, and go to the login page. So we're not going to do anything fancy. We're going to keep it nice and simple. But think about all the things that are happening here. We're having to start up the Selenium server. We have to start up the Firefox. We have to locate whatever version of the browser we want to run. We have to go to the login page. We have to know what the URL is, the URI, all that kind of stuff. So we're going to call our simple test, public void test, login page, and go. So now we're going to start using the Atlassian Selenium library. So what we want to do is we want to get an instance of a Confluence tested product. And how we're going to do that is we're going to use a tested product factory, which IDEA will automatically resolve for me, unless, of course, I'm doing a live demo, in which case it decides it won't. Oh, no, that's my fault. Okay, as we start any good story, every story begins in Maven. So I mentioned normally, at least the way that we did functional tests at Atlassian, is it involved a metric ton of Maven XML with all kinds of plugins and life cycles and phases that are bound to different things that are completely incomprehensible to anyone but the guy who wrote it. And then even then, 5 minutes later, he has no idea what he just did. It's an amazing power that Maven has. Sorry, I do like Maven. I shouldn't pick on it all the time. Two things I'm going to add here. I'm going to add two dependencies. Let me minimize that so we can see that a little bit better. Okay, keyboard shortcut, stop working, thanks. We'll do it old school. Oh, there we go, just a little slow. Yeah, okay, good. So we have two libraries here. One is browser auto installation, which we'll see in a minute. And then the second one is, both are Atlassian Selenium. The second one is Atlassian Selenium with specific Confluence support. So now we go back to our test, and we get to the second part of this exciting story, where we are going to create an instance of Confluence tested product. To do that, we need to tell it that we want to create a Confluence tested product.class. And then the second argument is the WebDriver instance. Actually, let me ask this. So a couple people, how many of you ever use Selenium? Forget plugins and all that. Ever use Selenium? Okay, so a little bit of Selenium now. How many of you ever use Selenium 2, which is also called WebDriver? Nobody. Okay, so that's oh, one guy. All right, that's cool. I hadn't used it before this last project that we started using it. So it's very new. It's actually only in alpha. So this is Selenium 2. I think they released alpha 6 a couple days ago. So it's pretty new, but we're kind of looking for a new way to do functional testing, and the API for Selenium 2 is way better than Selenium 1. So that's what I'll be showing here. So we need to get an instance of WebDriver, which is the main Selenium 2 class. Static import this method. There's three places we can get it, and I apologize, I couldn't figure out how to make this font a little bit bigger. But there's three places we're going to get it. We're going to get it for WebDriver browser auto install. How's that for a catchy name? Now that we have an instance of WebDriver, we're going to do confluence.go to login page. And we're going to start that up. Because, as you might have guessed, that's all you need to do to get going with a browser. So the default browser in the library is Firefox 3.5. So it's going to be building this test and taking its sweet time. Firefox 3.5 is going to start up, and it's going to go to the login page. Of course, Maven has to do its thing. That's the dance that helps Maven go. Did you ever find that? You ever do like little Maven dance when you're like, come on, compile? Okay, that's just me, apparently. All right, it's cool. Jeez, just hang me out there. Hey, did you see it? It was quick. You had to pay attention. Firefox started up. We saw the login page, and then it shut it down. So a lot of things are happening here, which is why I want to spend a little bit of time just on what happened. So first off, notice what we're not doing. As I already pointed out, we're not doing a bunch of Maven XML to start up Selenium and then shut it down after an integration test run. None of that stuff. It's all automatic. And in fact, you saw how it started up Firefox and then it shut it down when the test was over. It does that on a VM level. So if we had 15 tests, it would have started up Firefox once and shut it down once. Now in a perfect world, you would think, well, we should actually start Firefox every single test. Oh, dude, don't do that because your build times will just go crazy. So you want to find ways in integration testing. It's not like unit testing where you can be nice and isolated. You need to find a nice balance between isolation and performance. So the functional test took care of that for us. It started one Firefox and then shut it down. The other thing we're not doing here is notice I have not told it what the port that I want it to connect to. I have not told it the context path, the base URL. That's actually happening in the tested product factory. So if I drill down into that, you can see that it's doing a couple things. So when you're running within the context of amps, there is a system property, actually several, that are set to tell you about the environment that the test is running. There's one that tells you what HTTP port is being active, because amps could pick an open one, so it could be something different, and the context path and so on. So that's nice if you're running your build from Maven. But if you like to run your functional test from IDEA, you don't have all that information. So what this does is you can see the default annotation. It figures out what the default is. That's why I told it that I wanted a Confluence tested product, so it already knew what the default port and the context path was. So it's not a big thing, but it's this little piece of code that we've been copying and pasting all over the place, and now it just happens for you automatically. So both of these things I think are neat and kind of useful, but here's what personally my favorite feature of Atlassian plugin is. So if you remember Firefox 3.5, I said that's the default browser of this library. It started up. What's cool about this whole thing is that I don't have Firefox 3.5 installed on my machine. I actually have a completely different version of Firefox. What's happening is when the framework starts, it figures out what browser you want, defaulting to 3.5, detects what operating system you want, and then gets an instance of the browser for that operating system, installs it into the target directory, installs a profile into the target directory, and then starts up that browser. And I think that's important because that means no matter what environment your developers are on, Windows, Mac, or Linux, they get the same browser. No matter what browsers they have installed on their machine, no matter what version of 3.5, doesn't matter. Everyone is using and testing against the exact same browser. Now, just to prove how this is happening, let's do something kind of cool here. I think it's cool anyways. Then again, I am easily impressed, I will admit that. We drive up browser equals. So Chrome, any Chrome people out there that like Chrome? That's cool. That's a nice browser. Pretty damn fast too. It's handy. So what I want to do is I want to run the same test, but I want to use Chrome. Now I don't, again, as you might have guessed, don't have to have Chrome installed on my machine. So I will simply rerun my test. And it will find Chrome, detect my OS, find the Chrome zip. Did it happen yet? Oh, shit, there it goes. And it starts up Chrome. So again, this is coming from the library. Now this is something that Chrome does, figure out an open port. It keeps restarting because everyone has to do it differently. I think it finally found one. And it then opens a tab and then loaded it up and shut it down. So again, didn't have Chrome installed, and I just ran a test against Chrome. So you generally don't, I think kind of multi-browser testing is a cool thing, which we all want to do, but generally we get kind of stuck on the basics. It's kind of cool how I think Atlassian Selenium makes all that advanced stuff easy. Now right now I only have support for Firefox 3.5, and we have some support for 3.6 and Chrome, and so I'm working on filling that out so no matter what operating system you have those browsers available. So that's cool, I think it's cool. I showed you how you can get started with functional testing very easily without any Maven work, without any crazy APIs, and you can start testing your product very simply. That's all great. But someone asked, thankfully, up on that thing, what about Bamboo? What about our continuous integration server? How many of you guys use continuous integration? Okay, a good amount of you. So a continuous integration server is something that's going to be running your build for you to make sure it's still working. Great. But what if your CI server is actually a headless Linux box somewhere? Maybe if it is running on EC2 and it doesn't have Xserve running. And if you don't have an X server running, then how are you going to run Firefox? How is all these great functional tests ever going to work? So there's a tool called XVFB, for X window virtual frame buffer, I believe, which basically is a way that you can run an X window session headless, and then you can tell Firefox to connect to it, so it doesn't actually interact with the display. There is a Maven plugin that helps you use XVFB, because there's a Maven plugin for everything nowadays. You have the thing started up, and then you have your functional test run, and then you have it start shut down. As you might have guessed, next I'm going to show you how that's all built in as well. So let's take our test that we had before. We were using Chrome 6, and let's not do that. And let's set a new parameter, xvfb.enable true. So XVFB it's for Linux, and I think you can get it to work on any POSIX system, because I think you can get it to work on OS X as well. It is an external program that you're running, so what we're doing here in the library is we're actually executing it on the command line. So you can see down here, we've started XVFB on a certain display. One of the other nice things that's built into the library is if you're running on a build server, well, actually, let me step back, it's done. Notice what didn't happen. Firefox never started. You didn't see anything. That's because it ran in XVFB. So one of the nice things about how we do XVFB is you may, on your build server, you may have 4 or 5 builds running at the same time. They may have other instances of XVFB running at the same time. So it scans to find an open display port. Once it finds one, then it tells Firefox to connect using that one. So it supports running multiple things at one time. And we've had this running on our Bamboo servers for one of our projects, I don't know, for 2-3 months, and haven't had any problems with it, once we worked out the bugs. So great. I hopefully showed you how it's not hard to get started with Selenium, to get started with browser testing, have a consistent environment across your development team, and have it running in your build server. But the next problem, so that kind of gets you some of those things up on the board. The next problem is how do you structure and maintain your tests? Because it's one thing to get all this stuff started, and I think many of us have gone through the pain of getting it going, but then what do you do now? How do you start testing? There's so many things to test. How do I structure my test? How do I protect against their tests being brittle? And I think that's actually a really, really key point that I've hit a lot of times, is your tests are so brittle. They work great on the developer's box when they wrote it, and then they break later for some reason that you don't know, and you can't replicate it, and it sometimes breaks and sometimes doesn't. Such a pain. So how do we protect against that? The answer is actually not really in Atlassian Selenium, but it's a design pattern called page objects. How many of you ever heard of the page object pattern? Okay, a few people, but not many. This is actually, I think, one of the most, if you remember nothing else from the talk, and you say, yeah, screw your stupid little library, because you're mean. If you remember nothing else from the talk, remember the page object pattern. So what it does is it tells you to write a Java object to represent every page that you're going to be testing. So if you're going to the login page, you should have a login page object. If you're going to a dashboard page, you should have a dashboard page object. Then every operation that you want to perform on that page should be an actual Java method. So you go to the login page, you should call, I want to log in as admin, or log in with this username and password, and it does it. So there's a number of reasons why this is cool, but let me show you in code first, because I find that that makes more sense to me, and then I'll walk you through why this all just blew your mind, or not, whatever. So when I said go to login page, don't fight with me today. Login page. That's actually a page object. Now, Atlassian Selenium comes with a set of page objects. Obviously not every page in the whole system, but enough to kind of get you started. So it comes with one that we can go to the login page. And from the login page, I want to log in. And let's log in. I could log in as a user, but I'm going to log in as admin because that's a very common operation. Just made it a first-class method. Log in as admin. That's actually going to take me back to the dashboard page. And from the dashboard page, I want to assert. So that what I'm testing here is I'm testing that I log in as admin. And everything's working great. I'm going to change the name so it doesn't pick up that XVFB configuration. And I'm going to do my assert. Assert true, dashboard is logged in. And static imports. You know, I do love JUnit 4. I think it brings a lot of cool stuff. I hate having to static import my asserts. That is just a pet peeve of mine. Anyone else? JUnit 4? How many still use JUnit 3? Everyone uses JUnit 4? God, I'm such a curmudgeon. To use what?
I still use 3.
You use 3? Thank you. All right, one person. Yay for the Luddites in the audience. So I'm going to run this test, I think, once it decides it's ready to run. So as you can see, our test, the first thing you notice immediately is how readable, I think, how readable the test is. So it goes to the login page, and it worked, and the test passed. The first thing you know is how readable this test is. Notice there's not a bunch of crazy XPath expressions or selectors or wait loops or all that stuff that you have to do when you're doing Selenium. It's very obvious what's happening. In fact, I could have even made it uses a kind of a fluent chained interface pattern, so I could have actually chained all those statements into one. It's very obvious what's happening. I go to the login page, I log in, and I assert that I'm logged in. Your tests are smaller, your tests are readable, and your tests are then, as an extension, more maintainable. So you say, well, that's great, but surely you have to do all this WebDriver Selenium stuff. Fair enough, can't get away from that. But what you're doing is you're hiding all of that inside of your page objects. So before I get into that, let me just show you. So here's the login bit. As you can see, we have a username field, we have a password field, we're sending it keys. This is all the Selenium 2 WebDriver API. Then we submit the form, we set something internally, and then we return back a new dashboard page. So all the Selenium stuff is still there. You can't get away from that. You can't get away from having to add weights and all this complexity. But what you do is you hide it inside of the page object. Now why that is cool is if you think about it, as you're doing testing, you have one test. You could just put everything in the test method, sure. But once you add 2, 3, 5, 10, 20, 100, 100, and 200 more tests, every time something changes, you don't want to have to go into every single test and try to fix it. So if the login page changed, because I'm using the page object pattern, I change it in one spot only, and everyone benefits. So that makes your test more resilient to change, because let's face it, the UI is going to change. Your plugin, you may get that down, and then Confluence 4 is going to come out. Confluence 4.1 is going to come out, and everything's going to break again. But if we can isolate the change down into our page objects, we have a chance of having less brittle tests. So that's page objects. Very cool little thing, I think. Well, okay, so we've talked a lot of stuff about setup, but we haven't actually written our test. Let me do that now. So far I've been live coding. I'm not going to live code this part because I don't have quite the memory for that sort of thing. So I'm going to write a test, and we're going to automate that process that I went through with you manually, where we went to the dashboard, we clicked on the page, and then we added a comment, and then we clicked the like button and tested everything happened. So here's that test. Now I'm going to quickly add in some page objects. We're going to need 2 page objects here. We're going to need one page object, which is our demo page, with methods like actually like that comment, which is going to click on it, get the comment likes, and go to add comment page. So let's add our add comment page here. Now that one has a little bit more stuff here, where we're going to be doing a submit, for example. And I mean, here's the stuff that you just can't get away from, is all the Selenium things. So right now, how WebDriver works, let me back up. There's some great tutorials. I highly recommend you checking them out. But in summary, WebDriver is about finding a web element and then doing things with it. So you generally find it with a selector. And you can find a selector by ID or by class name. And if you use Atlassian Selenium, we have built-in support for jQuery selectors, which is a very easy way in a very small amount of code to find something. So here we're going to use a jQuery selector, which is going to find an LI with an ID of markup tab, and then we're going to find the child element that's a link or an anchor from there. And then we're going to click on it, and here's the wait stuff. You can't get away from that if you're going to write Selenium, where you wait for some condition to be true, wait for some browser Ajax-y stuff to happen before you continue on. So again, the Selenium complexity is still there, but you don't have to see it in your test. Make sure that we're cool. Are we cool? Come on. Resolve. Thank you. You know, it's with all the stuff the IDE does for you nowadays, it feels like, okay, so I come from a religious background. It feels like prayer. You know, it's kind of like it's all red. Come on, please, please, please. And then it happens. That's the best part. Which happens with prayer. Don't get me wrong. I'm not trying to offend anyone. Jeez, gotta be careful. Okay, so here's a test. So here's automating exactly all those manual things that we just did. We go to the login page. We log in as admin. We go to a link. So here's a little bit of the Atlassian Selenium framework working. We click on a link that's a dashboard link. That takes us to the demo page. We go to the add comment. We submit the comment on top of that. Returns back a demo page. Once we have the demo page, we get the comment. So we're going to get the very first comment because we know that there's only one. We like the comment, so we click on the like button effectively. And then we get now we have the comment ID. We get to see how many comments how many likes that comment has, and it should equal 1. So again, notice, very, very readable, very small. We're actually doing quite a lot of stuff all in this test, but it's very small and using that nice little fluent interface pattern, or chained method pattern, or whatever you want to call it today. It makes it very easy to, at a glance, see what's happening. And I mean, come on, let's be honest. If you've ever done Selenium tests or functional tests in general, trying to know what's happening when the method is this long, it's just impossible. Well, no, it is possible. So I'm going to run that test just to verify it works, although I have complete confidence in the demo gods today. So again, we're going to be going with the Firefox 3.5 that it's installed, and we get to watch the magic happen. This is probably one of my favorite parts. Well, one of the only things I like about testing is it looks like all this stuff is happening and you're not doing anything. It's kind of like sometimes I'll code in text editor just because, or compile Maven and just make it full screen just so all the stuff happens, so I feel like I'm really working hard. Okay, anyways, it's done. So it was pretty quick. I probably should have walked you through the demo instead of rambling. So this is great. I think this represents a big improvement over how at least I've done functional testing in the past. We came up with a lot of reasons why functional testing is hard and why people don't get involved. I think we've knocked off some of those, particularly around the setup ones and ways to make your tests less brittle. There is one other technology I just want to throw out there. I guess I do have a little bit of time, but I didn't do the coding for this because I'm lazy, that I think really takes the test to the next level. We haven't publicized this, we haven't talked about it, even though we've started to use it internally. There's a plugin which we wrote called the Func Test plugin. And where it really turns everything on its head is it allows you to write your functional tests as a plugin. So the functional tests are actually built and packaged as a plugin running inside of your target application. Now, if you think about that, think about all the cool things you could do. For example, let's take a look at this likes plugin. We did all the setup stuff where we created a comment and had it all, went to the demo page, had all that state set. Well, what if instead of clicking in the UI, what if we could have injected the page manager of Confluence and executed the page manager and added a comment that way? Or actually, I think we would have had to use the comment manager. Anyways, you do it in your Java code. So there's a number of reasons why this would be, I think, a huge improvement. First off, it's just way faster. Anytime you're going to be accessing the application directly instead of going through Selenium and JavaScript and loading and all that, it's just going to be way, way, way faster. In fact, if you were paying attention to the screen and not my ramblings when that last demo happened, you'll remember that actually most of that time was spent, I guess the login probably couldn't get away from, but it was spent adding that comment, waiting for the rich text editor, all the JavaScript stuff to load up so that it could add that comment and move on. If we could have added a comment in Java API directly, that would have made our test that much faster, times 100, 500, whatever tests. So it makes your test faster. It also makes your test less brittle, because anytime your test has to interact with the UI, that is a point of failure, because the UI is going to change. But if you can minimize your amount of UI interactions in your Selenium test, it will make your test more robust. Also, the Java API is much less likely to change over time, whereas the UI, you just have no idea it's changing. The Java API, at least the Confluence and the rest of the Atlassian developers are working hard to trying not to randomly remove methods, but deprecate and let you know. And if they did actually remove a method, your test fails immediately because you can't even compile the damn thing. Whereas in Selenium, if the UI has changed, you don't know it. All you know is have a red test, and you have no idea why. You have to dig through and step through, and even then, sometimes it works and sometimes it doesn't. So the Func Test plugin allows you to write your plugins, your functional tests, deploy them as a plugin, and have direct API. The final advantage, I almost forgot about this. The final advantage of this style is it lets you test any client API that your plugin exports. So if your plugin has a dynamic module type, or if your plugin exposes a service or a public component for consumption by another plugin, This would allow you to test that, whereas previously it was untestable. So I think the FuncTest plugin, when combined with the Atlassian Selenium, really starts to fill out a nice picture or a nice solution for helping to solve functional testing. Now again, functional testing, integration testing, particularly with Selenium, is always going to be hard, always going to be a pain, and always going to be something that you're going to have to weigh the pros and the cons. But hopefully with this library, I've shown that it's easier than you think to get started, and it's easier to use a browser. It's easier when you start structuring your page objects to make your test work better. So our final slide, before I get to that, actually, so I've come up here and we started the talk with getting all the reasons why you don't write functional tests today, and they're all valid. I completely agree with them. After I've shown you this library, I'd like to think that at least some of those are not a factor. So next year, 12 months from now, when I stand up here and talk about one of my least favorite topics, functional testing, and I ask the question, how many of you write functional tests for your plugins? I expect to look around and every single one of your hands better be raised. Thank you. Any questions? Yes?
You mentioned it downloads a browser. Where does it get it from? How do you get it behind a firewall? Can you have it like already downloaded in some area?
So the question is how do you get the browser? How is it downloaded? Does it work behind the firewall? Is it cached? Okay, so in the beginning I kind of trashed Maven a little bit just because that's my favorite hobby. But actually Maven does a lot of the hard work for us because the browsers, there's an artifact in Maven called Atlassian Browsers Linux, which contains all the Linux browsers. Now what happens is, and I don't know if you're familiar with this, but when we import Selenium, when we imported that browser auto install, the POM for that artifact had a couple profiles on it where what it would do is it would detect if Linux, then add this dependency. If Windows, then, yeah, so right, you create profiles and you say activated by the operating system or something. And so if Linux, then it includes this dependency which has all the Linux browsers. So therefore, all that Linux stuff, because it does get large, the browsers are quite large, is all taken care of by Maven. It's downloading it through the Maven Content Delivery Network, and it's caching it in our local directory so that it's very, very fast. You notice I kept starting it up, and I think it was actually installing the browser each time into the target directory, but it's very fast because Maven took care of a lot of that work for me. So yes, if you can connect to Maven, then this should work just fine. Yes?
What about latency? I mean, your example, you like it and then you count right away. And then that's the issue. What happens in between sometimes takes longer and you succeed right away. Do you wait for, or do you
Yeah, so the question is, so the question is when I did the demo and we click on like, there's that AJAX call that's asynchronous and it comes back. How did that code actually work? Did we do a wait for or something? Now, and my old solution to this, which, and if you're honest, you've all done this too, is thread.sleep, right? Just sleep for like a second or two. It'll just all work out. Yeah, right. So that's bad, but sometimes working beats, bad. Anyways, let me show you exactly how that works. So on demo, when you go to like comment, this is what's happening. So I'm finding the like comment, so that's the link, and then I'm clicking it, and then I have this wait until. This is a thing that's provided by, actually it's provided by the page object framework that they're using, but I think it's just wrapping something in Selenium. And then we have the condition. So we're waiting until the get comments likes equals 1. So if it had broke, this would loop for, I think, 10 seconds by default until it would have exited out. Yes?
Do you support Internet Explorer based on Windows?
Do we export Internet Explorer? Of course. Who doesn't? So how it works, you saw that I did Atlassian browsers, and I set it to Chrome-6, or I could have set it to Firefox-3.5. Instead of using those symbolic names, you could actually put in the actual path to your executable. And then you bypass all this browser installation stuff, and you're just using straight Selenium. So I could have put, I think, whatever the iexplore.exe, I could have said Selenium browsers, iexplore.exe. Then it wouldn't have tried to do any browser installation, only that magic. It would have simply found that executable on the file system and ran that. So, yes, it does work. Yeah, follow up?
Can we slow down the tests to look for false positives?
Can we slow down the test to look for false positives? I'm not sure this is your answer, but this is something I meant to point out earlier. If you've ever done Selenium before, you probably already know this trick, but people who haven't, one of the coolest things about Selenium is that I could go into my test and I could put a breakpoint. And so I run my test in debug mode, and then I can step through every single step and see exactly what's happening. Or if I'm writing the test, I could run an expression. IDEA and Eclipse supports this, where I could test out different assertions to see if they're going to work or not. So if I have a XPath query or a jQuery selector, I can see if that'll work. Now that's not perfect, because if you have some asynchronous stuff, it may work when you step through, but then when you run the test for real, it doesn't work, and that's because asynchronous stuff has happened. But it does make it a lot easier. Yes, in the back. The Func Test plugin, what product does it run in and what versions? Well, being a cross-product platform guy, it runs in every product, actually. I'm trying to remember. Let me go to the resources page. So that's the URL if you wanted to check it out. I think we have a couple releases. We're on 1.1, I think. This is being used for all the functional and crucible functional, the fisheye and crucible functional tests. They're starting to use a version of this. And we're also using it to test the platform as a whole to make sure all the pieces and parts are happy together. It works, I'm pretty sure it works in almost all products. I'm trying to remember, I'm sure there's a plugin version dependency where it has to be a plugin version higher or not, but I couldn't tell you off the top of my head. I would want to say plugins 2.5, because that tends to be one of them that is required. Plugins 2.5 is in every product except for, I think, Bamboo. And so that would be Confluence, oh shoot. I don't know. There's a whole matrix on the platform development page where we talk about the plugin platform development, which says which versions are in what products. Can I explain the zombie thing? Right, so I might have got carried away with storytelling and not meant to the point. Which part of the zombie thing? Oh, okay. Seriously, you have to try that game. It is such a fun little game. It's addicting, and I can play with my little 3-year-old, and he actually plays better than I do sometimes. I mean, he's moving and doing it, especially if you're an iPad. There's no excuse. iPad, it's just click and drop. And in fact, I think you can even play it for free on the web. So if you don't mind being in a web browser, and I think it may even run in an applet or some, no, probably not an applet. I don't know, however it runs. It's a very fun little game. Any other questions? Plants or zombie questions? Anyone? Strategy? No, probably not. All right, thank you.